In the area of science and gigantic mysteries pertaining to what was previously to the gigantic explosion, blended conversations and intrigued characters for quite some time. This enormous question doesn't just test how we could decipher the universe. It challenges the actual boundaries beyond which extends human knowledge. Imagining yourself at the brink of existence, investigating the immense, observing and pondering the contents that existed before our universe was envisioned, the Big Bang, as an event, marked the beginning of time, space, and all that we know. In any case, were you there a moment earlier in the past? This might have been a state of nothingness, a calm before the beginning of the cosmic gathering. And if this is accurate, maybe there was something much more alarming that existed before the beginning of time. As we dive deeper into this question, science takes us on a journey past the universe's beginning point into thoughts that challenge our consciousness. Physicist Brian Cox is well known for his investigations into the wonder of the universe. He suggests that surprise could have existed before the huge explosion, directing us to reconsider our ideas of reality and existence. In this examination, we'll dissect the science, the speculation, and the dazzling insider information that could explain what happened before everything else. We will explore ideas like self-important development, quantum changes, dark energy, and even multiverse. The responses might just paralyze you, yet they could also open up new perspectives on our position in the universe. Get ready to dive deep into a world beyond imagination and science, where the obscure still wins around the shadows, leaving scientists flawed and sometimes even upset. We ought to investigate what existed prior to the Big Bang and the reasons for these theories that test everything we thought we knew. To appreciate what may have existed before the Big Bang, we first need to meticulously examine what the Big Bang truly was. As scientists define it, the Big Bang means the point in time when the universe became extremely hot and dense, rapidly expanding to cause the growth of all matter, energy, and structure. When we look at the night sky, we see evidence of this explosive beginning with the expansion of all galaxies' directions from the origin point. But why did this happen? Furthermore, was there a period before this dense, hot start? According to the theory of cosmic inflation, there was, and it didn't even resemble a void. The peaceful expansion of a vast universe existed before the Big Bang, a state that was cold, vacant, and basically falling apart like an enormous vacuum. Yet this vacuum wasn't entirely empty. It contained a tremendous amount of energy that fueled the quick extension of space itself. Called inflation, this happened so rapidly that, in essence, it established the foundation for everything else. In a fraction of a second, space expanded at unfathomable rates until the expansion slowed down and the energy transformed into matter, particles, and the forces we now associate with the Big Bang. But what was the nature of this energy? Why did it suddenly grow the universe? And why did it stop? Experts think that this immeasurable expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric extending endlessly with tiny pockets of air forming here and there. Each air pocket represents a universe, including our own. This idea, called the inflationary multiverse, suggests that there are possibly limitless Big Bangs and an infinite number of universes. Ours is just one of many. This enormous, perplexing reality challenges our understanding of the universe as a whole, leaving us to inquire about other alternatives to the concept of nothingness before the Big Bang. This idea is speculative, not definitive, according to our current understanding. Even if you eliminate all energy, particles, and radiation from the universe, it still would not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inevitable tapestry of something, even in its most vacant state. Regardless of whether we can picture removing everything, these forces would still create a vacuum. Yet, the universe would still generate new kinds of energy. This reality alone is perplexing to experts. it suggests that true nothingness might be impossible within space itself. Our infinite cosmos has properties, rules, and constants that prevent it from being completely empty. Imagine creating a region with literally nothing in it. No particles, no radiation, no energy, except quantum fields and basic constants. These would still exist, implying that non-existence still has properties. For example, there's a peculiarity called zero-point energy, which represents the lowest possible energy state of quantum fields. Even in this state, particles can still momentarily appear and vanish, making a spooky resonance of movement even in what should be empty space. This challenges our concept of a real void and suggests that, yes, even before the Big Bang, something could have existed. Scientists are only beginning to understand one of the most astounding theories in modern cosmology: the chance of timeless expansion. If inflation could cause our universe, could it possibly exist if it could continue forever? Brian Cox describes an astonishingly vast inflationary multiverse where universes are infinitely produced and ongoing in expansion. Imagine each Big Bang as a flashlight igniting another universe, while different areas continue to experience inflation, making countless other universes. This cycle could theoretically continue indefinitely. The concept of vast universes leads to the fascinating concept of a fractal universe, where every new universe could actually cause its own Big Bang. Each universe exists as a separate, independent domain, not affected by others due to the rapid expansion of space. For researchers, this hypothesis is both exciting and alarming because it suggests a multiverse that never ends, with no predetermined beginning or end. Our universe may be just one part of a giant cosmic structure, forever expanding and constantly generating new universes. And what if the real disturbance in our view of reality is that there is no before or after, but rather a timeless pattern of universes forming and decaying? When we consider quantum field theory, the universe is not just a collection of space-traveling matter. It's a complex network of energy fields that fill the universe and connect to create all that we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields momentarily, obtaining energy prior to returning it. This phenomenon gives rise to virtual particles, substances that exist for a brief time, then vanish, leaving only a trace. The concept of virtual particles challenges the idea of a real void. Imagine a universe where there is no energy, no radiation. Would you have total nothingness? According to quantum field theory, in a vacuum, fields would occasionally produce brief particles like this constant motion in the direction of nothing. This suggests that the universe doesn't acknowledge our concept of emptiness. Fields and forces persist, releasing hidden energy into the universe that prevents combining quantum mechanics with general relativity, being the second most successful, yet currently incompatible theories in physics. This effort has given rise to fascinating hypotheses about the very fabric of reality and what may have preceded the Big Bang. One leading approach is loop quantum gravity, which posits that space and time are quantized, meaning they come in tiny, indivisible units, much like matter and energy. According to this theory, the universe didn't emerge from a singularity, a point of infinite density and zero volume, but instead bounced from a previous state. This big bounce replaces the traditional Big Bang and implies that a contracting universe preceded ours. Rather than reaching an infinite density, the contraction slowed and reversed, leading to a new expansion. This model challenges the idea of a beginning altogether. Instead of creation from nothing, it implies a cyclical process where universes collapse and rebound endlessly, governed by the laws of quantum gravity. Another groundbreaking theory is the holographic principle, which suggests that all the information contained within our three-dimensional universe might actually be encoded, on a two-dimensional surface at the outermost observable universe. If true, this would mean our perception of reality is similar to a hologram, and the actual origin of the universe could lie on this vast cosmic boundary. This idea emerges from studies of black hole thermodynamics, where it was discovered that the entropy, a measure of the disorder or information, of a black hole is proportional not to its volume, but to the surface area of its event horizon. Some physicists believe that the entire universe could work the same way, with what we see and experience being a propagation of more profound fundamental truths embedded in a distant cosmic membrane. This is taken even further by string theory, which proposes that everything in the universe, from particles to forces, is made of tiny vibrating strings of energy, and that these strings exist in a multidimensional space, possibly up to 11 dimensions. In this framework, our universe could be a three-dimensional brain, short for membrane, floating in a higher dimensional space. According to brain cosmology, our universe might have been born from the collision of two such brains. These interactions may not happen often, but they are colossal events that unleash enough energy to resemble strings. In this framework, there are many possible configurations. Each of these strings represents a different set of physical laws. The string landscape could imply that our universe is only one of many, emerging from its own distinct Big Bang-like event. The existence of such a landscape also brings forth the notion that other universes might have different strengths in different dimensions of gravity or even various kinds of matter. In this view, our universe might not be unique, but rather part of a multiverse, a collection of universes, each independently developing. The multiverse theory offers a hypothetical yet intriguing response to the question of what came before. The Big Bang, another universe in a different configuration, potentially leading to infinite cycles of creation and destruction with no definitive origin. In addition to these cosmological models, the role of black holes in shaping the nature of the universe has also been considered by physicists. A hypothesis gaining attention is that our universe may be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe, in which the Big Bang was the moment when such a black hole gave birth. This hypothesis applies to the universe, supported by the fact that, according to general relativity, the singularity at the center of a black hole is a point where the space-time curve is infinite, creating a region where the known laws of physics break down. It's possible that the harsh conditions within black holes could lead to the creation of new universes, which may suggest that what we consider the Big Bang was just the birth of our universe from the singularity of a long-dead black hole. Looking into these concepts necessitates a thorough investigation into the nature of time and its very essence. Some cosmologists speculate that time as we know it may not have meant anything before the Big Bang. If time began with the Big Bang, then there may have been no before in any conventional sense. This perspective suggests that time itself might have emerged from a fluctuation in the quantum world, or from a primordial state where the usual distinctions between past, present, and future did not apply. This could lead us to rethink the concept of causality, which relies on the assumption that events take place in a straight line. If time did not exist as we know it, then considering the issue of what preceded the Big Bang now seems absurd because there wouldn't be any temporal framework to support it. Further complicating the picture are theories of cyclic time. As mentioned previously, cyclic cosmology suggests that the universe undergoes endless cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent merely the most recent swing in an eternal series of universe cycles. These cycles might not be identical, but could evolve in different directions, each with unique physical properties. The cycle of the universe, according to this theory, would be an ongoing process without a true beginning or end, rendering the question of before the Big Bang, in the conventional sense, meaningless. The idea that time itself might be cyclical implies that each and every Big Bang could be followed by a contraction, with the universe relaunching itself in a never-ending loop. Another avenue of investigation into the nature of the cosmos is the potential of a primordial soup of particles and fields that existed before the formation of stars and galaxies. This concept suggests that, before the universe began its rapid expansion, it was filled with a dense mixture of elementary particles in a hot state, including quarks, leptons, and bosons, all in a state of extreme energy. These particles would have been interacting at very high temperatures and density, establishing the foundation for the formation of matter and energy. As the universe cooled, some versions of this theory suggest that this primordial soup existed in a place where quantum foam particles kept appearing and disappearing because of the uncertainty principle of quantum mechanics. The soup's properties have the potential to offer insights into the universe's earliest moments and, by extension, what preceded the Big Bang itself. Ultimately, what existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics improves, new hypotheses will continue to appear, providing increasingly complex and sometimes paradoxical explanations for our universe's origins, ones that we might never fully comprehend. The pursuit of this knowledge will continue to stretch the limits of human curiosity, driving us to explore the unknowable and its boundaries. As our understanding of the cosmos advances, new and bold ideas are proposed that challenge conventional thinking. For instance, some theorists suggest that the universe we observe may be part of a much larger multidimensional reality, where the laws of physics we know are just one set of rules governing one possible universe. This multidimensional view, where space itself could extend beyond the three dimensions we perceive, could have significant effects on the concept of time as well. In such a framework, time might not just be linear or cyclical, but could potentially have extra dimensions that we simply don't experience or that we are unable to perceive with our current understanding. Further complicating the investigation into the origins of the universe is the possibility that what we regard as the Big Bang might not have been the absolute beginning at all. It could be a part of a more extensive process where the current universe is just the latest iteration in a series of cosmic bounces or transitions between different states of matter and energy. In these models, the universe could have experienced multiple Big Bangs, each one representing a rebirth from the collapse of a previous universe. This theory, often referred to as the ekpyrotic universe or cyclic model, proposes that the universe goes through endless rounds of growth and contraction, perpetually resetting itself without a definitive beginning or end. Moreover, this theory could be connected to the mysterious phenomena observed at black hole boundaries. It's possible that black holes are gateways not only to other universes, but also to alternate parallel realities or timelines, potentially offering access to dimensions beyond our observable universe. This idea, while speculative, pushes the boundaries of what we understand about space, time, and the nature of existence itself. The speculative nature of these ideas doesn't diminish their potential importance. On the contrary, they challenge the very core of our understanding of reality. By investigating these enigmatic possibilities, scientists are not only testing the limits of their models, but also exploring the potential for entirely new paradigms of physics that could one day unite quantum mechanics, general relativity, and even a theory of everything that explains both the very large cosmic scales and the very small quantum scales. As we delve deeper into these unknown realms, one thing becomes increasingly clear. The search for answers to what came before the Big Bang will likely remain a central pursuit in both theoretical physics and cosmology. The profound mysteries of space, time, and the origin of the universe beckon us, and with each new discovery, we move closer to understanding the very nature of reality itself. Yet, the further we explore, the more we realize how much remains hidden, how much of the universe is beyond our current comprehension. The boundaries of existence may stretch far beyond what we can measure or even imagine. As our technology evolves and new theories are formulated and tested, the possibilities continue to expand, suggesting that the quest for answers will continue for centuries to come, forever altering our perspective on the universe and our place within it.